So you've been watching the channel, you're hooked on building ontologies, and you finally did it. You put together a data model for it, and now you're looking at it and you're asking yourself, does it know enough? Is it smart enough? Is it complete? And this is a question that anybody who's building ontologies has to grapple with. How do I know when I have enough information in the model itself? And this becomes especially apparent if you ever go try and sell to a client some ontology that you've built. So when I worked at Psycor, I worked on the sales team a fair amount, and I would go out to large oil and gas clients. And the first thing they would always ask us is, great, you got this smart model? What does it know about oil? What does it know about horizontal drilling? And these are great questions to ask. They are sensible questions to ask, and they are very tricky to think about clearly. It's worth a video on its own. Hello, and welcome to Ontology Explained. I'm Casey Hart, philosopher and ontologist, and today we're going to figure out how to answer that question, or even whether that's the best question to be asking. The thing that annoys me about this question is often clients who are asking me, what does this know about blah, expect that there's going to be some like crystal clear quantitative answer, right? You say, what does this know? What does this model know about horizontal drilling? And I would say, oh, it knows 83.5%. But that's not the way this works. In this video, hopefully we'll cover a little more of the shades there so that you understand better how to ask and interpret questions when you are building your own models or evaluating other models, or if you're in the industry, how you can best communicate these things to potential users of models that you're dealing with. And I'm going to have a controlling metaphor here because while ontologies seem complicated and weird, and they are, this question is very commonplace in another area of life, and that's in education. Every year we ask for every potential child, should they graduate to the next grade? Did they learn enough? How much do they know? Right? And this really is the same kind of question that's going on when we build an ontology and want to know whether it's smart enough to do whatever it is that we want it to do. So how do we think about students? One thing we could do is just say, what did you learn this year? We could count up the facts. And that's not a crazy thing to do. We say, congratulations, you've learned the 50 states this year. You learned the different branches of government. You learned long division and how to make some basic chemistry reactions. Wonderful. But once you start counting those facts, you realize how frivolous this feels. Like, is there a certain number of facts we are going to get to, which means you're good enough to move on to, say, the 8th grade or whatever? Is it 1,000 facts? 1,500 facts? How do we distinguish counting facts, right? If you learn the 50 states, is that 50 facts or is that one fact? Another thing that we do is we look at how much time kids have spent on various tasks. Over the course of this year, they've spent hundreds of hours reading and a lot of time in the science lab, and they wrote several different reports and papers. And this time spent on task is a proxy for how qualified the student is in being ready to move on to the next year. And I think that's great. But again, of course, that has the problem that you can spend hundreds of hours in a science lab and not learn any science, as any chemistry professor can attest to. So what we really go to almost every time here is tests and task evaluation. We have you write those papers and we grade them. We have you build a big project, and then we see how successful it is. We have conversations with you at the end of your philosophy course to see if you are conversant in the kind of concepts you need to be. We give you tests, and we grade how well you did. And those tests sort of have a proxy for counting the facts, right? Because the tests pull out a certain number of facts as a random sampling of all of the knowledge that you're supposed to know. And if you get 90% of the things on the test, then we hope that's representative of you having at least 90% of all the facts that we want you to know. And we decide whether that's good enough or not to move on to the next grade. So this is the move. Is it easy? No, student evaluation is really tricky, but it's a thing that we're comfortable with doing. And we can take those lessons and apply them to how you evaluate your ontology model. So the rest of this video is going to be structured by looking at how we can do each of those types of evaluation. Instead of counting facts, we're going to talk about counting nodes and edges in the graph. Instead of time on task, we're going to talk about how much dev time went into building the model and how much time it's been used running applications, etc. And then instead of a Scantron or SAT or GRE test, we're going to look at regression testing that see whether we've met the burden that we need in our competency questions. And then once we cover all of those, I want to spend a little step back for a second and say, what's behind this question of how much do you know? First off, how do you count stuff for a graph? And this is where ontologies are great. They're graphs, they are mathematical structure, and there are all sorts of mathy things we can do on these mathematical structures to count them. We can count the number of nodes. We can count the number of edges. We can count how deep the graph is. So if you have a hierarchy, right, of a taxonomy, you can say how many layers down do we have? So we can see something about sort of breadth versus depth on the coverage of concepts. We can look at the size of your instance data. So it might be that our T box, our theory box, where we say here are the kinds of vocabulary that we have, is relatively small, but then we have a whole bunch of things that are instantiated into those classes, right? So maybe we're only talking about patients and physicians, and that's only really two classes of things, but we have 15 million patients in our data set. So that's something about sort of the quantity. How much do we know? Well, we know a lot about patients, at least how many of them that there are in that sort of case. We can also look at the connectedness of our graph. So when you lay it out and see how densely populated are those edges. Do you have nodes that are pretty isolated, or do you have lots of edges that are coming out of them? A denser graph or more pathways through the graph mean that the graph is richer, it's more easily set up to run inference and things like that. So many good things to say here, and we could spend a long time on any of these individually, and if you would like to, feel free to drop that below in the comments. I'm just going to say a warning here, which is the warning of the tyranny of metrics. Once you start saying that our performance is indicated by this metric, we'll game the system. That's what's going to happen. I think that counting facts in this sense is useful, but if it becomes the key indicator that you're always looking to for important decisions, bad stuff is going to happen. So be careful. All right. Second thing that we can do is we can focus on how much time is spent on the graph. And one metric for that is development time. If you say, how much does this graph know about chess? And I say, I spent 1,500 hours putting information about chess into the graph. Does that tell you everything? No, but that is a good proxy for, if we think that Casey is good and doing quality work, then spending 1,500 hours of putting that sort of information into the graph does tell me that the graph is probably pretty smart. But then the other measure of time is just as, if not more important, and that's how much has the graph been used. So even if it's developed for a very short period of time, if it's getting used constantly and people are enjoying the results of the graph, then that is evidence that the graph knows what it needs to know, right? So this is powering this patient portal application, and we've had 0 bug reports in the last 2 months. This is where you put like all of your classic KPIs on the applications. So however you measure what makes an application good or not, if some application is leveraging the graph and it's meeting those performance indicators, then that is evidence that your graph knows enough. And we shouldn't overlook this. I think it's totally worthwhile. Now we can move on to the big one, which is testing. Here is my story for how we would build a use case. If you were to hire me to build some POC or something like that, or if I'm recommending to any of you ontologists out there how to get a project going, first you want to have some clear, here's a thing that we want done. And then here is the sort of knowledge that we're going to need to capture in order to accomplish those things. And the way you lay that stuff out is you make competency questions. So you say, okay, I want to do this chess ontology, right? That's the other video series that I'm working on right now. Go check those out if you're interested in how this flow might happen. You say, I want to be able to answer what opening was used in this particular game. What are some traps within that opening? What makes a pin or a fork? And I write out in clear English, here are the things that I want my model to be able to know. And then I solve my use case. I put that information in the graph. I write queries against the graph that answer those questions in ways that I wanted it to. And then whenever you've built this application and it's functioning the way you want it to, you need to make regression tests. In fact, better practice is even once you make the English competency questions, to make the regression test to start with and say, here's a test that will tell me whether I've successfully answered each of those questions. You build out the model, and once you're answering those questions correctly, then you know that the model knows enough, at least relative to those representative questions. And you keep those tests running because, of course, your model is going to change in the future and you want to make sure that there's no backsliding, right? So we keep that stuff in there. And then you just iterate. So we ask this one question about, okay, in this particular chess opening, are there any traps? And are there any forks that are part of that trap? I don't know, something like that. And then you back off from that and you say, can I ask a related question? Does it work for this other opening? So I looked at it in the Grunfeld defense, but what happens in the Roy Lopez or something like that? if you can take the work that you did on one tranche and apply it to another tranche and it works just as well, then that is evidence that you've made stuff as general as you need to. Sometimes that works, oftentimes it doesn't work. But when it's not as general as you need it to be, you say, okay, well, how did I need to change or add information in order to handle this other question? And then you do it again and you do it again. You just iterate, right? And hopefully, as you're doing this process, you're not just, each time teaching to the test, but rather saying, how can I get some more general knowledge in there so that it's going to be right on one of these arbitrary other choices that I make? It's tricky. But once you get the hang of how you can ask questions in a more general fashion so that you're less and less teaching to the test and you are actually surprised and happy that it's handling these new and novel cases, then that's evidence that you're building your ontology at the right level of generality. And that's evidence that you know enough. So for testing, make good and clear regression tests that are a representative sample of the stuff that you want to know and make sure it's answering those correctly. Again, does this tell us everything? It's only as good as your testing is. Okay, so we've looked at the 3 ways that you can evaluate the goodness of an ontology by counting sort of mathematical features of the graph, seeing how much time was spent on it and how much time it spent working on things, and then generating tests and making sure that it's answering those tests correctly and hoping that those tests are representative of what makes the ontology smart enough. So let's get to the real question, which I think often underlies this, what does your ontology know about X thing? And that real question is, we have some task that we want accomplished. And if you don't know about this, we don't even think you can do that task. Now, maybe that's true, and that's fine if that's the case. But often I didn't know about, the ontology didn't yet know about some particular set of facts, but it would take me like 2 hours to put those facts in there. The difficulty wasn't getting that knowledge into the ontology. The difficulty was figuring out how we could leverage it to solve that bigger problem. And so if your clients or your boss or you are thinking, oh, I don't know enough about this, take a step back and say, is there a more important question here that I'm asking? And let's stay focused on that. Because, if all you need me to be able to say is like list all of the hospitals in Texas or something like that, and I don't know any of them, well, if you've got a table that has all the hospitals in Texas, I can put that into the graph in 2 minutes, right? So going back to that chess example again, in the last chess ontology video, we added 1,800 openings to the ontology in 30 minutes or something like that. So it can often be very fast to put a bunch of information into the ontology. The real question is, okay, what do we want that for, and how can we drive the ontology and the knowledge to make that stuff happen? What's our road look like to ending up where we can deliver value for you? Those sorts of things. Insert your business speak here, however you like it. It's economies of scale, deliver value, meet all your KPIs. Man, this has been a very business lingo-y heavy video. I got to get away from that. Go back to the philosophy stuff. Let's summarize what we covered. So it's incredibly reasonable to ask what an ontology knows about something, but it's actually a little more complicated than you might think at first. There's not just the answer is 93. There's no quantitative single answer that's going to tell you how much your ontology knows about something. I can maybe think of some rare cases where you say, oh, we know 100% of the US states. Well, fine. Then there's like a quantitative measure. But most of the time you say, what do you know about emergency departments? There is no single number or answer that is going to satisfy that. And you should distrust anybody who tries to give you a single quantitative answer to a complex question like that. However, we can do a lot in terms of answering how much your ontology knows about things. And for that, we use that metaphor of thinking about how do you know when a child knows enough to move on to the next grade. For our ontologies, we can count up nodes and edges and properties of the graph. We can calculate how much time has gone into developing the graph and how much time that graph spent being used, along with the various other performance indicators of how successful that usage has been. And we can build tests, and you better be building tests. Build your regression tests, people. It's super important. And when we're successfully answering those questions, then we know our ontology knows what it needs to. But fundamentally, make sure that you're focused on the primary question that's probably underlying all of this, which is, I want you to know this stuff so you can do this thing for me. Know what that thing is, and the barrier to entry might not be as hard as some people are thinking when they're first asking this like more reasonable but vague question about how much does it know about this topic. Thanks so much for watching this video. Let me know in the comments how you tend to handle things like this, or if you have further questions that drive from this. And just a reminder that a performance indicator for how much I know in this video is how many likes and subscriptions there are to my channel. So it's silly. It's crazy. I know. We all know that I'm super informative and this is incredible. But if you can help some of those other people out there in the algorithm out find me by liking and subscribing, I'd much appreciate it. Hope you're all having a fantastic day. Have a great one tomorrow, too, and I'll see you next time.